Hi, ladies and gentlemen. This is Miss Jermaine. Just give me 1 second while I just turn my screen around, and let's take a look at this afternoon work for today. So what I'm actually going to do in this video is, I know that in class we went through and we did 1 through however many we got through, but I figured make one sort of video for class in the afternoon, so that it's a little bit easier for us to sort of get everything all organized. So what I'm going to do is I'm going to start with number 1, and I'm going to go through all 11 of these reviews for today. So let's take a look at Ms. Albert. So Ms. Albert determined that 4/3, comma, negative 4/3 was a solution to a systems of equations. Your job is to test whether or not Miss Albert is correct, or if she is wrong. So the way that we're going to do that, we have a set of points here, and we have the two systems, and we need to decide, are they solutions, yes or no? We need to remember a few things before we get started. First, that points are written x, comma, y, because we're going to need to take these coordinate points right here and plug them into both of the equations. You need to plug them into both of the equations to make sure that it is a solution, because it could be a solution to one of them and so not a solution to the other one. So we're going to plug it into both and solve. So I'm going to take my first equation. I'm going to say 8 times my x value here is 4/3. Plus 2 times negative 4/3, okay, and is going to be equal to 10. And then my second one is going to be 5 times 4/3 minus, Miss Jermaine, use the right sign, minus 4 times negative 4/3 is equal to 15. Okay, so let's take a look at the first one here. So 8 times 4/3. I grab my calculator. Whether it is your phone, whether it is an online calculator, you're going to multiply 8 times 4 is 32 over 3. And let's see if that goes in evenly. No, so I'm going to leave it as 32/3. And then I'm going to say plus 2 times negative 4/3. So negative 2 times, or 4 times negative 4 times 2 is negative 8 over 3. And it's got to be equal to 10. So I add these guys together. I say 8 plus negative 32 plus negative 8. So 32 minus 8, and I get 24. It's kind of hard to see. 24/3 is equal to 10. I do my division here. I get 24 divided by 3 is equal to 8 equals 10. That is a no-go. This is not a solution. You can go through and solve this guy here, but because it's not a solution for one of the equations, it's automatically not going to be a solution for the system. So this guy is not a solution because equation 1 is false when you plug in. Okay, so it's not enough for you to say, no, it is not a solution. You need to give me this reason of, because when I plugged it in, it didn't make a true statement, or because when I plugged it in, it made a true statement. So you have to give me both in order to get full credit for that quiz tomorrow. Pause the video if you need to copy any of this down. I'm moving forward. Okay, let's take a look at number 2. Okay, number 2. We have number 2. It says, which of the following systems has no solutions? So if we look at these guys, we know that they are in y equals mx plus b, or slope intercept form. Okay, so that means if I want no solutions, I want you to take a second and think about, what does that mean? Like when you're looking at these equations, not graphically, what does it mean, no solutions? in the y equals mx plus b form, which was really what we talked about in the previous unit and we touched upon yesterday in class, we said that no solutions, when you're looking at y equals mx plus b, it has the same slope or that idea that I sort of introduced yesterday. It was called a coefficient. And a coefficient is simply the number attached to your x, right? So the same coefficient or the slope, and if it's no solutions are constant or our y-intercept is different. Actually, I don't want that there. Okay, so that's what we're looking for graphic, or when we're looking at these equations, is you're looking for the same slope, different constants. So if I look at this guy here, I have the same slope, check, but I also have the same constants. That is not going to be my guy. Now, if I look at B here, I have the same number for these slopes, but they're not the same slope. Don't get tricked, because one of them is a positive and one of them is a negative. So this guy is going to have one solution because it has different coefficients here, or slopes. Very good. So this one is not going to be our guy either. Don't get tricked. Don't do it. Okay? Even though it has these same constants here, it's still going to be one solution because those variables are different, or our slopes. Good. Now, if we look at C, we have our slope of 1/5. We have our slope of 1/5. Ooh, we're good. We're halfway there. Now, it needs to have the different constant. If we look at this guy here, does it have different constants? I have a positive, a negative 20 and a positive 10. I have y-intercepts of negative 20 and positive 10. Those are different. So this is going to be our guy. Let's check this last one to make sure. Okay, so if we look at these guys here, I have a 10x and a 1/10 x. I mean, like, so if I was to try to like test it, I could say like times 10, no, times 100 times 100 to get a 10x, right? Negative, and then that would be negative. Too big. So this guy is not. So I would say no on this guy as well, because we have different coefficients and different constants. So no go on that guy. So C is our answer here. Check your work and make any changes that you need to. My suggestion to you is I would give this a second attempt because you have multiple attempts on this guy. I would give this a second attempt going through with all the answers so that you can get 100. So that's just a suggestion. Here we go. Let's take a look at number 3. Number 3, it says graph the systems of equations on the grid below and then mark their points of intersection, point C. So what I'm going to do is I'm going to come around here because this sort of requires me to do some clickage. So give me one moment while I just turn my screen back and let's take a look at it together. Okay, so I'm going to move me out of here because like I'm beautiful, but I don't need to be here. And we look at this guy here. So we need to graph these two equation lines. So we need to graph one that has a y equals 3x plus 3. So that means line A is going to hit my y-axis at 3. And it's going to have a slope of, it's going to have a rise of 1, 2, 3 for every one that I run. Boom, that's equation line A. Now, for equation B, I need to do some work with this. I mean, I can't, no, I got to do some work with this. Got to do some work with this. So I'm going to take it over here. You're going to do this on a separate piece of paper. Negative 2x plus y is equal to negative x plus 5. So you could put this into standard form, but don't do it to yourself. This kind of isolate to get this y by itself. It's already by itself, so we don't even need to do any division. I would add 2x to each side, and I would be left with a y is equal to a negative x plus 2x is, oh my gosh, you're right. A 1x plus my 5. Oh my gosh, that was so easy. Crazy pants. I need to graph that guy. So I need to come to my graph. I'm going to click this line B. So what I think is important here is that you pick the right line for each one, because I think like this one has to be line A and this one has to be line B. Like you can't like switch them. So make sure you're doing the right one for each. So this one has a y-intercept of 5 and a slope of positive 1. So if I come here, I click my line B, I put my y-intercept here, I go up 1 over 1, it's going to intersect here, and my point C, I'm going to click on that guy and click where they intersect. Boom. There we go. That is number 3. Pause it if you need to fix or do this again, and we're going to move forward. Okay, let me just turn my camera so you guys can see me. Okay. Here we go. Question number 4. What is the solution to the following systems of equations? So we have a couple options that we can do with this one. We can do substitution. Nah, I don't like it. Because I would have to do a lot of division to get one of those variables by itself. Don't do it. I could graph, but I don't have the graphing option and you need to show work. So that's not going to work. We have to do some elimination. So if we look at these equations here, I'm going to do a little bit of work here, and then I'm going to come over into this section here to do some work as well. So I have a 7x plus 2y is equal to 24. I have an 8x plus 2y is equal to 30. I see what looks nice to me is these y's are sort of easily eliminatable, but I would say I sort of like to classify them as like kindergarten, middle school, high school, and college. This is definitely a middle school level difficulty where like there's one step that we have to do before we can start to eliminate. So the step that I would do with this guy here is I would choose one of these equations because these two y's are both positive. We're going to have to make one of them negative by multiplying by -1. So I'm just going to pick this first equation because smaller numbers. I'm going to say -1 is going to be distributed to my 7x plus my 2y is equal to 24. Okay, and I'm going to distribute. It's going to be a -7x minus 2y is equal to -24. Bring my other equation underneath. I have my 8x plus 2y is equal to 30. And I add those two systems together, okay? So when I do that, these cancel out. I'm left with a -7 plus 8 is a positive x is equal to a -24 plus 30 is a positive 6. So x is equal to 6. So in theory, you can like take that 6, plug it into one of your equations, and get your solution for your y. You could say, in this case here, 7x plus 2y is equal to 24. I just picked the smaller one. 7 times 6 plus 2y is equal to 24. 7 times 6 we know is equal to 42. Plus 2y is equal to 24. Subtract 42 from each side. Okay, we're left with a 2y is equal to 24 minus 42 is -18. Divide by 2, y is equal to 9. We can check our work. This one's pretty cool because we have like options here. Final solution. I know that does not say final solution, but it like glitched out. X comma y, 6 comma -9. Our solution here is A. Boom. Nailed it. Wait, you missed it. That was like a basketball. Awesome, awesome, awesome. Let's take a look. Okay, number 5. Okay, solve the systems of equations below algebraically. So we have these two systems of equations here. I'm gonna rewrite them just because like they're not lined up and like I don't aesthetically not the biggest fan. So we're gonna say 2x plus 3y is equal to 6. We have negative 5x plus 2y is equal to 4. Okay, I'm just going to go through and make that 2 a little bit nicer so that we know what we're talking about. I want to take a minute to look at these and figure out which strategy is probably going to be the best here. So I'm looking at these and like I could do substitution, but I mean, I'd have to like do division, and like this 3 isn't easily divisible by a 2, would be like a 1.5. And I don't want to do halves, guys. I hate to say this, but like elimination is probably the best method here because we don't have graphs to graph them with. So we're going to need to use elimination. So I'm going to say to myself, which one of these guys, this is like college level difficulty because I don't have like, because I can't like multiply either one of these equations. Like if I'm looking at my x's and my y's, there's no number that I can multiply by that could like easily like cancel it out. So we're going to have to multiply both of the equations by some number. So I want to cancel out my y's only because like I have a positive and a negative, and they're like I won't have to multiply by a negative number. So I'm going to multiply this first equation by 5. I'm going to multiply the second equation by 2 to cancel out my x's. So I'm going to say to myself, 2x plus 3y equals 6. And I'm going to multiply that by 5. And I'm going to multiply that all 3 terms. This is going to get rewritten as a 10x plus 15y. Plus a 15y is equal to 30. I'm going to get 2 distributed to a negative 5x plus 2y is equal to 4. And then distribute. Okay. And I'm going to get a negative 10x. Oh, God. Plus 4y is equal to 8. So I have my 2 new equations here. I need to do my elimination. I need to set them up and do it out. So I have a 10x plus 15y is equal to 30. I have a negative 10x plus 4y is equal to 8. Okay, these x's cancel out when I add together. I have a 19y is equal to 30 plus 8 is 38. I'm going to be like super assuming here. I'm going to divide by 19. Y is going to be equal to 38 divided by 19 is 2. I have a y of 2. Now I need to take it and plug it into one of my equations. I'm picking this guy. He's nice and small numbers. Don't make it difficult on yourself. 2x plus 3y is equal to 6. I have 2x plus 3 times 6 is equal to, substituted the wrong number in there. You caught me. 3 times 2 is equal to 6. 3 times 2 is 6 is equal to 6 plus 2x. Minus 6 minus 6, I get a 0 is equal to 2x. Divide by 2, divide by 2, x is equal to 2. Now I have to plug them in as x and y over here. So I'm going to write in here a 2 and no, a 0, a 0, a 0, a 0, a 0. Don't get confused. A 0 and a 2. Boom. Pause it, go through it, get your stuff written down if you need it. On the quiz, you will be required to show work, so please make sure that you know how to do the work. Okay, here we go. Okay, 6. I got this guy here. Solving the system using any method, be sure to show your work on the scratch pad or on a separate piece of paper. Boom, x comma y. I have, oh, okay. I love this guy. This guy is nice. I have a y is equal to equation. A one variable is equal to something. I can substitute. Yes. Oh, I love it. Okay, so I said y is equal to, so that means in this second equation here, for my y, I can substitute this piece in. I can say 2 times y, which is 3x plus 6, minus 12x is equal to 12. Okay, I'm going to substitute, I'm going to distribute here. 6x plus 12 is equal, no, minus 12x is equal to 12. I need to combine my like terms here. I have a 6x and a negative 12x, which combines to a negative 6x plus 12 is equal to 12. I'm going to subtract 12, subtract 12. Oh, I just figured out what the x is going to be. I'm going to get a 0 is equal to negative 6x divided by negative 6 divided by negative 6. X is equal to 0. Plug it in and solve for your y. Take the first one. Don't be silly. Pick the first one and plug it in. Y is equal to 3 times 0 plus 6. 3 times 0 is 0, plus 6 is y. Y is equal to 6. Final solution, if we write it as an ordered pair, x comma y, 0 comma 6. Pause it if you need to go through and get any of this written down. Here we go. Number 7, halfway through now. Solve the following systems using any methods. Be sure to use this show work through Scratchpad. Okay. This is the one. This is the one where you really, really, really can choose any method of substitution or elimination, because both of them are going to be really, really easy to do. So if I were to, for example, I could say for this first one, I could subtract 3x from each side to get the y isolated. That's one way. I could multiply this first equation by 2 and use it elimination. I am going to do the elimination because it's trickier. And in class, I did the substitution. So here we go. I'm going to multiply that first equation by 2 because then the y's will cancel out. 3x, so we're going to say 2. 3x plus y is equal to negative 15. Distribute it out here. We're going to get a, oh goodness, 6x plus 2y equals negative 30. Okay, bring down my second equation here. Negative 6x minus 2y is equal to 30. Okay, so if I look at these equations here, x's are going to cancel. Oh, Mr. Man. X's are going to cancel. My y's are going to cancel. We're going to be left with 0 is equal to 0. Okay. Let's think. So it's not going to be like x is equal to something or y is equal to something. So it's not going to be one solution. So it's going to be either like infinitely many or no solutions. So it's going to be either no solutions or infinitely many. Okay, so now we need to figure out which one it's going to be. So if I want to look at this guy here and I have to, let me think. How could I do this? Okay, well, so if Now we can make the decision. So if I have a 6x, I'm going to distribute a negative 2 here. A negative 6x minus 2y is equal to 30. Okay, and I take my second equation and I plug it in down here and I say negative 6x minus 2y is equal to 30. Okay, so now we can make the decision. Is this going to, so we know that it's not going to be one solution. Now we need to decide no solutions are infinitely many. We need to use this idea that we talked about in class yesterday when we're looking at equations and deciding the number of solutions. We have the same, if we're looking here, we have the same coefficients. And we have the same constant. And I'm using that word constant here because this is a standard form equation. So our coefficients are the same, our constants are the same. What kind of solution does that mean we're going to have here? Oh my gosh, you're right. Infinitely many solutions. So on this box right here, I would put IMS. Okay, when you get this back, it's going to give you your score. I have to go in and hand grade this one, so don't be concerned. Awesome job. Nice job, guys. Pause it if you need to go through this one again. Okay. Nice. How many solutions would there be for the following systems of equations? So I have, oh my gosh, this one's crazy. I have a y is equal to, in a 3x minus 5, and a 6x minus 2y is equal to 10. If you look at these guys, they're in different forms. My first equation here is in standard form. Slope-intercept form, y-intercept form. And then the second one is in standard form. So we're going to have to convert them one way or the other. I suggest, because I'm looking at this guy and like I have this 2, so that means I'm going to have to divide by 2. This is nicely divided by 2. This is nicely divided by 2. So I'm going to convert this second equation here to a y equals. So I'm going to say 6x minus 2y is equal to 10. Okay. And I need to get this y by itself. So first thing I'm going to do is subtract 6x from each side. Okay, I'm going to be left with a negative 2y is equal to 10 minus 6x. So now I want to get this to be a single y, and I want to make sure that I keep the sign. I take the sign away because I can't have a negative y. So I'm going to have to divide by negative 2, divide each term by negative 2. Okay, so then these cancel out. I'm left with a y is equal to negative 5. Negative 6 divided by 2, negative 2 is a plus 3x. Okay, and then so then I have my second equation here, and I'm going to write it over here just because I need to do something to this first. So we're going to say a y equals 3x minus 5 is that first equation. And then I want to look at this and sort of rearrange it because I want to be a little bit better. So I can say to myself, I can rewrite this as y is equal to keeping the signs 3x, a positive 3x minus 5. Now I can compare them and figure out how many solutions this is going to have. Oh my gosh, look at that. It's the same. Because we converted to y-intercept, y equals mx plus b form, they have the same slope, or I've been using that term coefficient. Okay, and we have the same intercept, negative 5, negative 5. So this one is going to have infinitely many solutions. Awesome, awesome, awesome job. Nice job, guys. Fantastic. Pause if you need to. Here we go, number 9. Okay, how many solutions does the system below have? Okay, so we have oh gosh, this is nice. Oh my gosh, guys, come on. We have y is equal to negative 6x minus 7. Y equals negative 6x minus 7. Oh my gosh, stop it. How many solutions does this have? Same slope. Remember, I've been using that word coefficient. Okay, and the same intercept. And that other word that I've been using for an intercept is that number that's all by itself is the constant. Okay, same slope, same constant. That means we have infinitely many solutions. If you do this drop down, I just want to see like what the options are here. What are my options here? One solution, no solutions, or infinitely many? Infinitely many. Boom. Nice job. Let's look at the next piece. Okay, determine how many solutions exist for the systems of equations. Let's take a look. No, this guy's not 9. Oh no. Oh no. Wait, this is literally the same question that we just did before. Weird. Okay, so very similar. So I have these equations here, and they're in different forms. If you look, we have a standard. No, this is different, so don't skip past this because this is different. Standard. Okay, and we have our slope intercepts. So we need to do some conversions here. I need to get it to be either y equals or convert it to a standard form. Listen. I don't really want to convert it to standard because I'm going to have to like do a lot more. So I'm going to convert this first equation to a slope intercept form. So what I'm going to do is I'm going to say negative 6x minus 2y is equal to 10. I want to get or isolate my y by itself. Okay. First thing I'm going to do is get my x over to the other side by adding 6x to both sides. Okay, I'm going to be left with a negative 2y is equal to 10 minus 6x. Okay, now get my my y by itself. I need to divide by negative 2, divide by negative 2, divide by negative 2. Both of the terms need to be divided by negative 2. Cancel out. We say y is equal to negative 5. Oh goodness, we did do this one before. Plus 3x. And if I compare it to my other equation here, actually, it's different because we have a different equation. Y is equal to negative 3x minus 5. If we look here, compare our slopes. They are different slopes. When we have that idea of different slopes here, automatically, you don't need to do any more work. You know, when they have different slopes or different coefficients, we're going to have a one solution type deal here. Boom, let's look at the hint. Boom, and that's what we did. One solution, next to row. Last one, okay? Write a systems of equations to model the problem. Shireen, you got this, girl. Okay, here we go. Okay, so we have to write a systems of equations to model the problem. At the movie theater, one family buys 3 bags of candy and 5 boxes of popcorn and pays $30. Another family buys 5 bags of candy and 15 bags of popcorn for $45. How much is 1 bag of candy and how much does 1 bag of popcorn cost? So first, we're going to use the variable C, and that's going to represent the number of bags of candy. Okay? The P is going to represent the number of bags of popcorn. Okay? Pause if you need to write that in. Write an equation that represents the first customer. Use the variables we used above. So let me scroll this guy down and let's take a look. Okay, so we need to write an equation for the first piece here. So if we look at the first guy, they buy 3 bags of candy. So 3C plus 5P is equal to how much money did they spend? $30. Very good. Pause and write that in if you did not get this. Okay, write an equation for the second customer. Okay. Second customer buys 5 bags of candy, 5C plus 15 P is equal to $45. Okay. Now we need to solve the systems of equations. I'm going to write this over here. I'm going to like scroll this guy down a little bit, and then I'm going to use the space down here and over here to solve. So we have the equation of 3C plus 5 P is equal to 30. We have 5C plus 15 P is equal to 45. Okay, so I know if I multiply, I can cancel out my p's here. Multiply my first equation by -3. -3 times 3c plus 5p is equal to 30.
So when we distribute it out, we get -3 times 3c gets me a -9c. -3 times 5 gets me -15p. -3 times 30 equals -90. Then I'm going to set that equal to, I'm going to get my other equation here, and I'm going to copy and paste it in. And I'm going to cancel out my p's. And once I cancel out my p's by adding these two equations together, -9 or 9 -4c is equal to, oh, that wasn't typing, sorry about that, guys. Stuff is underlined. -4c is equal to -4c is equal to -90 plus 45 is -45. And we divide each side by -4, divide by -4. We get a c value equal to 11.25, or 11 25 hundredths. That is equal to my c. Now I'm going to use that c value, and I'm going to plug it into one of my two equations. I'm just going to grab the first one and plug it in and solve for my p value. How much is the popcorn going to cost? So once I do that, I'm going to say 3 times 11.25 plus 5p is equal to 30. Okay, from there, 3 times 11.25 gets me a total of -33.75 plus 5p is equal to 30. Get that p by itself by subtracting 33.75 from each side, minus 33.75 from each side, and we are going to get a negative, well, actually, let me show you what we're going to get. We're going to get a 5p is equal to, 5p is equal to -3.75. Okay, now to get that p by itself, we need to divide by 5 on each side. And now this is where it's going to get a little bit tricky. We have a p that is equal to, I'm going to just sort of space it over because I don't really have much room here. A p that's equal to -0.75. So if we need to think about what these mean in the context of this story, let's think about what this means in the context of this story. In the context of the story, the solution means that a bag of candy costs how much money? Candy costs $11.25. 11, you can do it two ways. You can say $11.25, or you can say dollars at the end there. Then we talk about the popcorn costs, and just say it in the way that it's equal to. It's equal to -0.075 dollars. I want you to take a second and I want you to think. Does that make sense? Is that a logical answer? Can we say that that is a correct answer? Think about it logically. No, that doesn't make any sense. Popcorn can't cost a negative amount of money. So when we look at this last question, last part, and now we need to think about it in this context of F here. If a customer buys 30 bags of candy and 19 boxes of popcorn, how much will they pay? So there's two correct answers that I'm gonna take for this one, because you can give me like logically what does it mean, right? You could say like logically I take this equation and I say that if the candy costs $11.25 and the popcorn costs negative 0.25, we could plug it in and solve it, and it would look like, for example, 11.25 times 30 bags of candy, okay, plus the negative 0.75 times the 19 boxes of popcorn is going to equal some amount of money, some T amount of total money. And I can do both of those multiplications. And this equals, so 11.25, 20 times 30 is $337.50 plus negative, or we could say minus, 0.75 times 19 and get 1425, and that would get us our total amount equals our total amount. When we do this 337.50 minus 1425, we get 323.25. But if we think about that, so that's one answer that I'm gonna take here is 323.25, because logically, like, I mean, so like not logically, but like in this story, that's how much it would cost. But now I want us to think about it like thinking about it logically in the way that you're not going to pay negative 0.75 for something. Unless you're like an extreme couponer, but like I don't think you guys are extreme couponers. So what we could also substitute in for the price of this would be zero, right? We could say $0 times the 19 bags of candy or popcorn that we buy, because maybe they're giving it away that day because it is a promotion. And then it would be that $373.50 minus $0 is going to get us a total amount of money of $337.50. Okay, so the two answers that I'm going to collect for answers on this one are going to be either this 337.50, because that's if you're thinking about it like logically, and then you're talking about this 323.25 if you're thinking about it like algebraically. So I'm collecting two answers for this size because this one was a little bit more of a challenging question. So once again, I am going to be going in and correcting these. So if you didn't necessarily get the right answer, please don't fret, because I'm going to go in and self-correct them, okay? So awesome job today, ladies and gentlemen. I know this was a little bit tricky, but you guys are fantastic. I will see you all later. If you have questions, let me know.